I'm delighted to welcome our first session of the day, which will hear us discuss the work that Rakuten OSS is doing with zTouch. And to deliver this session, firstly, I'd like to welcome our guest speakers, Salvatore D'Oro, the co-founder and CTO of zTouch Networks, and Tommaso Melodia, the Director of the Institute for the Wireless Internet of Things at the William Lincoln Smith Professor at Northeastern University, and representing Rakuten Symphony, the Head of Sales for the Americas, Anshul Bhatt. I'll hand over to you, gentlemen. Thank you very much.
Hello. Thanks, James. Hey, everyone. Good morning. Looks like an early start for day 3. Anshul this side from Rakuten. We are here to talk about the approach, the pragmatic approach to slice management that we are working on with our SMO RIC platform, along with Northeastern University, zTouch, with Professor Tommaso Salvatore. So let me just kick off with some introduction around our intelligent operations portfolio in general, and then some of the SMO RIC capabilities we got, and then we'll hand it over to zTouch to go through the RAP and the slicing framework that they are working on. So I think we briefly mentioned this during our launch on Monday, that how intelligent operations 2.0 vision is, like we are building a foundation layer with AI agentic framework in mind. These are some of the key modules that consist of the intelligent operations platform that we got. A lot of use cases around closed loop automation, service-based modeling, full stack observability, some of the AI ops component where you can essentially configure playbooks right from network monitoring, analyzing, decision-making, and action orchestration. And a lot of NOC teams who are embarking on this vision of dark NOC, they are using our platform across several operators within US, Europe, and of course in Japan, Rakuten Mobile, to do the day 2, day 0, day 1, day 2 operations. So some of the this overall platform is based out of the agentic architecture, but also what we have done is we have embedded this into the SMO RIC philosophy, whereby we have some of the standard interfaces that are needed to operate like a RIC platform and some of the RAPs on top of it. And we have done the ORAN compliance as well. So for our SMO and RIC vision, this is the platform that it's built on. So let me just double click on some of the use cases that this platform empowers when it comes to ORAN specifically. Our philosophy is in order to take the full, or in order to leverage ORAN and its full benefits, it is essential to have an automation strategy in mind. And that's where, using this Rakuten Intelligent platform, we are delivering some of the SMO use cases that operators are leveraging this for. So zero-touch provisioning is one of the key ones. And what we mean by zero-touch provisioning, I think we have mentioned this before too. The entire process, right from network planning all the way to site on air, is something that we manage through this platform in our zero-touch provisioning module. Some of the aspects of planning, like it could be IP planning, host naming, it could be the nominal planning. Instead of just taking a traditional approach, we have a data-driven vision to perform that, and that's what we mean when we say digital RAN planning. The site acceptance process after the site installation is done, be it the physical installation checks, be it the drive test, static and dynamic drive tests, or be it some of the configuration, golden config audits and things like that. So we have automated that bit as well. And that's what we mean when we say auto ATP. And then when it post on air, there are a few features around auto healing, complete software lifecycle management, which includes managing the software stack across all the layers or in the ORAN domain, right from the computes to the applications, even including the radio unit, and some of the components around the physical network functions such as firmware, BIOS, etc. So the entire lifecycle management, telemetry, ops automation, and at the end of the day, it's all about leveraging value out of platform, whereby we have a few RAPs and analytics portfolio, whereby we use the RIC interfaces ORAN compliant interfaces in order to perform some of the analytics. And I think this session is also going to dive deeper on one particular use case around network slicing that we are working on with zTouch. So just double-clicking on some of these, architectural aspects, as mentioned before, that this platform leverages like a common services philosophy where we have observability, data, AI available as platform components, on top of which we have created some adapters and layers and modules to perform analytics across multiple domains, closed-loop automation, and even we have a developer studio where users can configure playbooks right from monitoring, analyzing, decision-making, action orchestration, providing cross-domain, multi-domain use cases that deliver value to NOC. So this is how the architecture looks like. It works on any cloud. It's completely cloud-native, microservices-based architecture. And now let me just go into some of the detailed features that I mentioned earlier at a high level. So we have the end-to-end observability stack. And on top of it, we do some of the ML-based autocorrelations, anomaly detection kind of frameworks in order to get insights in a smarter way instead of traditional business rule-based telemetry. We have config management, RCA, and zero-touch provisioning, as I mentioned earlier. And then when it comes to day two operations, we have auto-healing, slicing kind of use cases available too. And lastly, I think the real enabler for ORAN and open ecosystem, our RIG platform, which is now available, and we demonstrated yesterday some of the early results from Rakuten Mobile on energy savings and other things. So we will dive deeper into the RIG platform in this particular session, where we are having partnership with zTouch on having their RApp on our platform for network slicing and intelligent slice management. Apart from just the auto healing and slicing aspects, we also have covered the other aspects of ORAN as a domain, including transport and bare metal. And that's where some of the lifecycle management pieces around network upgrades, automation, automation around transport network is available. And lastly, we do have a service desk kind of a module where we not only just use or have like rule-based ticketing system, but whatever incidents are getting created in the system and whatever people are doing once those incidents are created, the platform keeps a track on that. And then we are able to recommend some of the AI-powered insights around how to improve the efficiency around ticket incident management, as well as what should the next action be based on the actions that they have taken manually before. So I think these are some of the features that we wanted to touch at a high level from the framework SM or RIG perspective. Now let me hand it over to Dr. Tommaso from zTouch and Northeastern University to dive deeper into the partnership and the R apps and X apps and D apps that zTouch is bringing on our RIG platform. Over to you, Professor.
Thank you, Anshul. Good morning, everyone. Early start. We're excited to be here to talk about the partnership between zTouch, Northeastern University, and Rakuten Mobile and Rakuten Symphony. This has been a partnership in the making for a little while, and I think we're getting to the heart of it, when things are really happening. We see a lot of momentum with this technology, and we're quite excited. zTouch is a spin-off of work that has been done at Northeastern University over the past 5 years in developing the future of open, programmable, and AI-powered radio access networks. And it's developing what we like to call an AI-based operating system or AI-based operations for 5G and beyond. Okay. So the problem that many of us here are trying to solve is that 5G networks are increasingly complex. We have coexistence between public and private networks. We're trying to create differentiated QoS. There's a number of technologies that are making heterogeneity of devices, heterogeneity of spectrum, heterogeneity of protocols that are coexisting are making the network much harder to manage. The complexity is exploding, and we need to develop technology that will automate the provisioning, the deployment, the configuration, and the operations of the network. We're going to do that through programmability and AI. to enable a future of networks that can learn to configure their behavior to reduce the total cost of ownership for operators. Okay, so zTouch Network is developing two different main products. What we call zTouch OS. zTouch OS is a cellular operating system, right? It's a platform that enables automation, inference, and control on the radio access network based on AI, and eliminates the complexity of AI and RAN operations for non-expert users and for complex deployments. We're also developing zTouch SDK, which is a software development kit, APIs and templates to automate and streamline AI design, generation, and onboarding for O-RAN networks. The idea is developing situations where you can customize your network behavior in minutes or seconds. You define at a high level the behavior that you want your network to achieve. For example, create a slice that can minimize latency, reduce the energy consumption, and allocate specific portions of the spectrum. That is defined at a high level on a dashboard. zTouch OS takes a catalog of applications that includes R apps that run on the non-real-time RIC, X apps that run on a near real-time RIC, and D apps. This is a new concept that has been proposed by Northeastern University for applications that run directly in proximity with the radio access network, including on the DU or CU. And all of these applications can, in real time, reconfigure your network behavior, provision the entire network, and obtain the behavior that you want to achieve. This is what zTouch is developing, and we're very excited to partner with Rakuten to bring some of these technologies to fruition. A little bit on the architecture of zTouch. zTouch obviously can work with a lot of different partners. So we have our own catalog of platform services, R apps, X apps, and D apps. zTouch sits close to the SMO and can take all of these applications and implement them on third-party non-real-time RIC, near real-time RIC, or RAN. So we can work with partners that can bring their own non-real-time RIC or near real-time RIC, take our own applications and deploy them on the platform. And similarly, we can work with third-party core network, different services to provide all of these behaviors. And this is just architecturally a little more detail on the zTouch platform. I want to emphasize that all of our applications, all of our X apps, R apps, and D apps are built on data. Built on data that is collected from real live networks and from a lot of the testbeds that exist today at Northeastern University. All right, I'm going to hand it over to Salvatore D'Oro, who is one of the co-founders of zTouch, and he's going to talk today about our demos here, particularly the slicing demo and the automation demo.
Can you all hear me? All right, I can hear myself, so I think you can. Okay, so thanks for the introduction. I'll kind of try to focus myself primarily on the some of the aspects that are related to network slicing and how these technologies are going to be used for this partnership with Rakuten. And I will skip directly to a video that I want to show you. Let's say, I'll go very fast here. All right. Okay. So let's see if the video starts. Okay, so I want to show you this demo, which is the demo related to network slicing. So at zTouch, what we have developed is an X app that is able to prioritize certain type of traffics, and it's fully integrated with the dashboard. Let me pause 1 second here. Oh, no, let me. Oh. All right. So what I want to show you is that the network slicing is basically an XApp. So we have developed this XApp that implements RAN slicing following 3GPP specifications for RAN slicing. In ORAN, this is implemented using the E2 service model for cell configuration and control. So we have developed an XApp that is completely integrated with and compliant with ORAN specifications, and it's integrated with the intent management platform. And so basically users, what they can do is they can, in real time, control and reprogram the network slicing XApp based on priorities that they have at that moment. For example, they can specify which slice they want to prioritize. So they can say, for example, I want to prioritize at this time a slice 1 or slice 2, for example, prioritizing video streaming or prioritizing IoT sensing data and so on. So what you will see here, this is the integration with the zTouch framework, and basically you have like the intent management platform that integrates with the RAN, integrates with the neural time rig where the XApp is executing. And what we're doing here, we are instantiating two UEs that are connected to the base station. Each UE is assigned to a certain slice ID. And then what you will see is that we, in real time, will be reconfiguring the slicing XApp so that we can prioritize one or the other. One slice is doing constant file transfer at 50 megabits per second. The other slice will be doing video streaming live using Dash. So what you will be seeing is that once we prioritize one slice or the other, video streaming quality will be impacted. So what we want to show is that if you prioritize, for example, file transfer over video streaming will be experiencing a lower performance in terms of lower bit rate. In the way around, you will see the data transfer will be going down. So I will be starting the video now again. So now what we are doing is we are instantiating the two UEs. In this case, we're using commercial smartphones. We are starting the first UE. This is a 5G module that we are activating. And this is running a 50 megabit per second file transfer that is constant. And then what we'll be doing is instantiating the second slice, which will be the user that will be performing real-time video streaming, which is what you see here to the right. And now what we do is we deploy the XApp, the network slicing control XApp. We target the specific G node B that we want to control. So you can implement different slicing policies on each different G node B. We deploy the intent, so the XApp gets deployed. Now the system is operational, so we can start the traffic. And what you will see here to the right is that the video streaming will start soon. And once the video streaming starts and we run the system, you will see that here there is a dashboard that will be populated with the performance of the network. So here, for example, we are showing that there are the two UEs. One slice is related to the green color, another slice is with the yellow color. So you see here the 50 megabit per second file transfer. This is the video streaming app that now starts. Dash works in a way that basically buffers the video frames. So what you will see is that there are peaks where it goes to up to 4 megabits per second. This is a 4K video streaming that gets buffered. And what you see here, at the moment, we have implemented no slicing priority policy. So it's what we call free for all. So everyone is getting pretty much the same performance. We are not prioritizing anyone. And then we start prioritizing slicing 1. Slicing 1 is the video streaming application. So you see that the video streaming application is still running at 4K, and you see that the 50 megabit per second now went to 4 megabit per second, because we are prioritizing the video over the data transfer. So this is kind of like impacting the performance, of course, of this video stream of the file transfer slice. And now what we'll be doing is we'll be converting that back to prioritizing instead the file transfer over the video. And this will show here that the video, of course, there was a buffer, so we will just like going fast, and here we'll just going ahead and see that the video stopped. Because now what happens is that the video has lower priority, so it has to switch to a lower quality video quality. And you see that the video now, it's not 4K anymore, but it's 6040 by 36. So this is something like a very low quality video. And this is kind of like something that shows you that you reconfigure and can push policies to the XApp in real time. You can determine which slice you want to prioritize. And this kind of like is something that you can control in real time. And with Rakuten, we will be working together on how to integrate this into a production network so you can really use AI and use programmable control to prioritize one slice over the other. And I think we can probably, for the sake of time, stop here. All right, thanks everyone.
Ladies and gentlemen, a big round of applause for our speakers from zTouch, Northeastern University, and Anshul Bhatt, the head of Global Petaproc Sales for North America. Many thank you, gentlemen, for that session.